When a jet breaks the sound barrier, it doesn't just make a boom. It reshapes the air around it. A sonic boom is the sound of air being forced to move faster than it can get out of the way. Sound is simply vibration, a series of pressure waves that travel through air. When an object moves slower than sound, those ripples spread ahead in smooth circles. But once it goes faster than sound, the waves can't escape. They stack up and merge into a single sharp front called a shock wave. That wave races outward and downward. And when it sweeps over you, you hear it as a deep rolling boom. The speed of sound isn't fixed. At sea level and room temperature, it's about 343 meters per second, or roughly 767 miles per hour. When an aircraft reaches or exceeds that speed, it's flying at Mach 1. If it goes twice that, it's Mach 2, and with every increase in Mach number, the geometry of the shock changes. Those shock waves don't form in front of the aircraft, but behind it, spreading out in a cone shape called the Mach cone. The angle of that cone depends on speed, sinh theta, cr1m. At Mach 2, the cone angle is about 30 degrees. At Mach 1.2, it's about 56 degrees. The faster the aircraft, the narrower the cone. The boom you hear comes from that cone hitting the ground. Every point under the flight path gets its own moment when the cone passes overhead. That is why the boom follows the aircraft all along its route, a moving carpet of sound. A supersonic plane actually creates several shock waves, from the nose, wings, and tail. When those reach you, they combine into an N-wave pattern. A sharp pressure rise, a gradual fall, then another sharp rise. It is that pattern that produces the classic double boom, two quick cracks separated by a fraction of a second. How loud is it? A typical sonic boom creates a pressure change of 50 to 200 pascals, less than 1/100th of normal air pressure, but it happens so suddenly that it rattles windows and echoes like thunder. Altitude matters. The higher the plane, the weaker the boom. Aircraft design matters too. Long, slender shapes spread the shock energy and soften the sound. Engineers now shape airframes specifically to reduce boom intensity, a technique called boom shaping. Even small objects can do it. A whip's crack is a tiny sonic boom, the tip moving faster than sound. High-speed bullets and meteorites make them too, though on a smaller scale. In modern projects like NASA's X-59 are testing quiet supersonic flight, spreading out those shocks to turn the boom into a gentle thump. If it works, we might one day fly faster than sound without the windows rattling below. So, what exactly is a sonic boom? It's the audible footprint of an object outrunning its own sound waves. A sudden, sweeping shock that marks the boundary between ordinary speed and something extraordinary. It's not an explosion. It's the sound of physics catching up.